Well, in this video, we will learn about summation notation, summation formulas, approximating the area of a plane region, upper and lower sums for the plane region, and area by the limit definition. Okay, so first is the summation notation. For the sum of the n terms like a1, a2, a3, an, we can write this as a sub I from 1 to n is this big sigma. Okay, so we expand this one, so it looks like when I is 1 and put I1 where the I is, so it becomes A1. And this tells you we put plus sign and then put I equal 2 becomes A2 and so on. Just keep putting I, value of I where the I is here and right here until you reach n. So basically summation of AI for I from 1 to n is basically A1 plus A2 plus A3 and so on up to plus AN. I is called the index of the summations, and 1 is the lower bound or lower limit you can say, and n is the upper bound. Here we have few summation formulas. So let's see summation I from 1 to n of a constant. C is like a constant. So it's simply C times the upper bound, Cn. And here we have a summation of I from 1 to n. So it looks, the B should come out n times n plus 1 over 2. And summation of I squared, I from 1 to n, it comes out n times n plus 1 times 2n plus 1 over 6. Here is summation of I cube, I from 1 to n squared times n plus 1 squared over 4, and so on. Okay, here we have example number 1. So we want to find out what is the summation of 5, I from 1 to 10. Well, here C is 5 because 5 is constant and n is the upper limit or upper bound, which is 10. Well, to find this one, we can use this formula summation I from 1 to n of C, which is equal to C times n. So here we just substitute C equal 5 and n equal 10. So we'll get summation I from 1 to 10 of 5 is 5 times 10, 50. So you can check this one. Summation I from 1 to 10 of 5 is simply when I is 1 is 5 plus I is 2 is 5 and so on. You write 5 10 times, and if you add all this you will get 50. So here we have an example 2. We're going to find out I from 1 to 10 of I summation. So let's see, here n is 10. We need this formula summation of I from 1 to n, which is n times n plus 1 over 2. So we just substitute n 10 in this. So you get 10 times 10 plus 1 over 2. So we 10 times 11 over 2, which comes like a 55. This you can check also. Summation of I from 1 to 10 is when I is 1, this I becomes 1. When I is 2, this I becomes 2. When I is 3, it becomes 3, and so on. When I is 10, it becomes 10. And the plus is because of this notation summation here. So basically it tells you write all the terms and put plus symbol. Now if you add all those, 1 plus 2 plus 3 up to 10, you will get 55. See, this for using formula is easier than doing this one. Okay, so here we have example 3. We're going to find out summation of I squared, I from 1 to 10. Now here, n is 10 now. Now from the summation formulas, we know summation of I squared, I from 1 to n is n times n plus 1 times 2n plus 1 over 6. So we just substitute n equals 10. So this formula becomes 10 times 10 plus 1 times 2 times 10 plus 1. So this becomes 10 times 11. This will be 20 plus 21. And you multiply and divide by 6 using any simple calculator. So you should get 385. Okay, so here we have example 4. So we're going to use the summation formulas to rewrite the expression without summation notation. And we're going to use the results to find the sums for n equals to 10, n equals to 100, n equals to 1000, n equals to 10,000. Yes. So that's what we have. Summation I from 1 to n 5i minus 1 over n squared. Okay, so well, here the variable is I. So n squared is constant. So we can factor out n squared as 1 over n squared. So you have a now summation I from 1 to n 5i minus 1. And as you know, single summation can be broken down into sum or difference of summation. Since a minus here, so we can rewrite summation of 5i and summation of 1. Now we can factor 5, and so here we factor out 5. So you have now 1 over n squared parentheses 5 summation I from 1 to n, and summation of 1 I from 1 to n. So we need two formulas. Well, for first formula, we can use this summation of I is equal to n times n plus 1 over 2. For the second one, we can use summation of C I from 1 to n Cn. So we can write this 5, and we can write this n times n plus 1 over 2, and this should be what? C is 1, so it's a 1 times n. Okay, now we distribute the 5, so it becomes, and also n, so it becomes 5n squared plus 5n over 2 minus n. Okay, and now we change, and we want to subtract n from this 1, so we can change, since LCD is 2, so we can write n as 2n over 2. Same denominator, so we can now write 5n squared plus 5n minus 2n over n times 1 over n squared. Okay, now we can simplify. So you will have 2n squared on the bottom, and you have 5n squared plus 5n minus 2n will be 3n. Okay, so we have now summation of 5i minus 4 over n squared becomes 5n squared plus 3n over 2n squared. Now we substitute n equal to 10. So it becomes 5 times 10 squared plus 3 times 10 over 2 times 10 squared. Yeah, put on the calculator, you should get 2.65. Now we want to find when it's 100, basically the value of this one. And this is, if we have this one, so we substitute n is 100. So it becomes 5 times 100 squared plus 3 times 100 over 2 times 100 squared. And we put on the calculator, gives you 2.515. And we can use the same from this formula. We can use n equal to 1000. So it becomes 5 times 1000 squared plus 3 times 1000 over 2 times 1000 squared. So it comes out 2.5015. Similarly, we can substitute n is I think 10,000, and we can 5 times 10,000 squared plus 3 times 10,000 over 2 times 10,000 squared. So putting in the calculator, so you should get 2.5000015. Okay, now here we're going to define lower sum and upper sums. Well, lower sum is the sum of the area of the inscribed rectangles. Meaning rectangle lying inside the ring, just like, you know, you see that all rectangles are under this curve. No rectangle is crossing over this curve. Okay, so let y is equal to f of x. It has to be a continuous function, just like this continuous. You see there's no break in this curve. And with closed interval x, you can start with a to b. Again, this has to be. And we can make colors triangles. This one just like this one. So this is a plane region, and this plane is bounded by the this curve f of x, and this vertical line at a, and another vertical line b, and the x-axis, and we're going to find this basically the area. So what we're going to do, we're going to subdivide this into rectangles, and then we find the area of each rectangle, and then we add all those areas, and that will be the area under this one. As you notice, there is a space left over. See, this one. So the area will find that will not be the actual area. It will be the smaller than the actual area. So let's go here. First we find we want to draw the rectangles of the same width. So how are we going to determine the width? Well, here's the code. Delta x we use for the width, and that's what you do. You subtract this lower value from the upper value, b minus c, and divide by how many rectangles you want to make. So let's say we want to make n rectangles. So that's the width. Okay, now we can write the endpoints of the intervals. So like this endpoint and this endpoint and this endpoint and so on, all these endpoints. So the first would be, you can write x of 0, and that would be the where the a is. And the next is you add this width, which is this b minus c over n, which is delta x. So we write x1 is a plus delta x. And this, then the next would be you add delta x in the previous one, it becomes a plus 2 delta x. And just keep adding and you keep getting until you get the last endpoint. So in this way, here are the endpoints we are getting. So the first endpoint is x of 0 is a, x1 is a plus delta x, x2 is a plus 2 delta x. So it looks like to get the next endpoint, you just add the delta x to the previous one. So here x, now remember these are left endpoints. So we write, now next is x of I minus 1. So we write a plus 1 I minus 1 times delta x. And the xn minus 1 becomes a plus n minus 1 times delta x. And the last one, the nth, that's the b. Okay. Now we define mi, little m star, mi, or lowercase mi, left endpoint. And that's the formula we're going to use throughout in this section, the next section, a plus I minus 1 delta x. Okay, so we substitute this mi value in the original function, and that's the lower sum, I from 1 to n f of mi times delta x. So basically say this is the height of the rectangle, and this is the width of the rectangle, and this is the area. And so say total of this area going from I from 1 to n. So you can break it down if you want. You can write f of m1 times delta x plus f of m2 delta x plus f of m sub 3 delta x and so on. Okay. All right. Similarly, we can define m sub I, the right hand point. So right hand point will be defining as a plus I times delta x. As you know, a is this is the lower end, right? Lower value of the interval. And I basically tells you the which rectangle, and delta x is the width of the rectangle. Remember, delta x width is the same we're using for convenience. Now, did you notice here all the rectangles, they are crossing over the curve? So that means this little area is the counting mode, right? So if you add all the areas, and the area, total area would be more than the area under this curve and above this x-axis and between these two lines. So actual areas. So but here we write upper sum would be function evaluated at mi times delta x. So that's the upper sum, which is basically the area of circumscribed rectangles. So clearly you can see this area, if you use this formula to calculate the area, that would be more than the actual area. So the lower sum is the less than the actual area. The upper sum formula give you the more area than the actual area. Okay. So here's another way, finding the area by the limit definition. So basically same thing. So we can use one of the formula which we discussed, either lower sum or upper sum. for convenience. So let's hear how he defines. If a function is continuous, function has to be continuous. There shouldn't be any break in the function, and non-negative on any interval AB. The area of that region bounded by the graph of f, the x-axis, and the vertical lines x equal to a, x equal to b, as you saw before in the pictures. That would be f of ci times delta x summation I from 1 to n, and we're going to take limit and approaches infinity. Basically, we're saying more rectangles we draw, better will be the approximate area. Okay. So we're going to say we're going to draw infinite number of rectangles, and we're going to find the area using this formula, and we're going to add all this. Okay, so what is CI? CI is the left-hand point, and I have to remember left-hand point. You can write, this is the formula, a plus I minus 1 times delta x. Or you can write CI as the right-hand point, and that should be what? A plus I times delta x. And what is the delta x? Delta x is the width, and its width depends on how many rectangles you wanted to draw. And the width would be, you subtract the lower value of the interval from the upper value, and then divide the number of rectangles you wanted to draw. So just for convenience, we use letter N. Okay. So here we have example. We're going to use the formula just discussed before. So here we're going to use the limit process to find the area of the region bounded by the graph of the function and the x-axis over the given interval. The interval is 0 to 1. So here, this is the region. We want to find the area of this region. So what we're going to do is we going to use those upper sum or lower sum formulas, or the formula we just discussed. So here, let's see. First of all, we need to know what is delta x we're going to use. I mean, the width of the rectangle we're going to draw here in this region. So it will be b minus a over n. And b is 1 and a is what? 0. So 1 minus 0 is 1, so 1 over n. So delta x is 1 over n. Now we're going to choose right-hand point. It's easy to use right-hand point than the left-hand point. So I think I could suggest to use always the right-hand point. So we'll get the same result. So let's see, sub I is equal to a plus I times delta x. Well, a is 0, so we put 0 here. I is I, and delta x we just calculate 1 over n. So we simplify, it becomes I over n. So Ci is I over n. Now we're going to write the summation notation, and we're going to use C I over n with the axis. Okay, so let's see. So now we substitute with the axis Ci, and Ci is what? I over n. So this becomes f of Ci equal to minus 2 times Ci plus 6. And we're going to replace the Ci, which is what? 1 over n, I over n. So it becomes negative 2 times I over n plus 6. We simplify, gives you minus 2I over n plus 6. Now we're using the upper sum formula, and this is what? I from 1 to n, f of Ci delta x. So now we substitute this information in this formula. So f of Ci is minus 2I over n plus 6, we just found here. And the delta x is just 1 over n. And now we write this summation notation I from 1 to n. So now we distribute 1 over n. So you will get summation I from 1 to n minus 2I over n times n square, and 6 times 1 over n is 6 over n. Now we break it down into two sums. The first becomes minus summation of 2I over n square, I from 1 to n. The second would be what? Summation of 6 over n, I from 1 to n. We can factor 1 over n square in the first summation. We can factor out 1 over n in the second summation. And we have this one. So the upper sum is negative 2 over n squared summation I from 1 to n of I plus 1 over n summation I 1 to n of 6. Now we're going to apply this formula because we're going to replace this summation by this simple expression. So summation of I we know is n times n plus 1 over 2. So we get minus 2 over n squared times n plus 1 over 2, n plus 1 over n. Now for this one, we need another formula which simple is what? 6 is constant, multiply with n. So with 6n. Now we basically simplify. So it looks like n and this is n squared, they cancel out and give you of n. And 2 cancel with a 2, so you get minus n plus 1 over n. And this n cancel out, so become plus 6. Now we take, the area will be now we take the limit, because that's the formula, is limit n approaches infinity of minus n plus 1 over n plus 6. Now if there are two functions, so we can break it down into limit, sum of two limits. So we limit n goes to infinity, n plus 1 over n, plus limit of 6, n goes to infinity. Well, limit of 6 is 6 because it's a constant. But to find this limit, one of the suggestion is that you break it down, you divide individually. So you get n over n plus 1 over n. Simplify. So the limit n goes to infinity from 1 plus 1 over n. Now we substitute n infinity. So it becomes negative 1 plus 1 over infinity plus 6. Well, 1 over infinity is 0, so it becomes 1 plus 0. So it becomes negative 1 plus 6, it becomes 5. So here is another example. We're going to use the same limb process to find the area of the region bounded by the graphs of f of x, 2x squared plus x, and over this interval 0 to 3. And also the x-axis. Okay, so f of x, this is a like a quadratic function. It's a parabola, is continuous, we know. Right? Okay, so it's a continuous and non-negative. Okay. So we partition this one into n subintervals, each of width. First find the width of the subintervals, or the width of the rectangle we're going to make. So delta x would be, remember the formula is b minus a over n. And the b is what? 3. And the a is what? 0. So we become 3 minus 0 over n, which is 3 over n. Now we choose any x value in the subinterval for this example. We can use right-hand point. Can remember right-hand point is easier. So right-hand point we call c sub I, and I think it's a plus I delta x, and a is 0. So that's why I have a 0 here. Okay, so and delta x 3 over n. So we have now 0 plus 3 over n times I, which becomes 3i over n. And now we're going to substitute this ci in this original function. So if we do that, we have f of ci equal to 2ci squared plus ci. But ci is equal to 3i over n. We just calculated. So this becomes 2 times 3i over n whole square plus 3i over n. Now we just square this one, it becomes 9i squared over n squared plus 3i over n. Okay, so we have ci. Now we write area is the limit n goes to infinity, summation I from 1 to n of f of ci times delta x. Okay, so this becomes limit n goes to infinity, summation I from 1 to n. And fci we just have is this one, 18i squared over n squared plus 3i over n times delta x, which is what? 3i over n. No, I'm sorry, delta x is 3 over n. Now we distribute this one here. So this becomes summation 50, like 18 times 3 is 54, I squared, n times n squared, n cubed. And this will be, and I also, you can, 3 times 3 is 9, and also we have broken down into two summations. We have multiplied and broken down into two summations. Now we're going to factor out n cube, or 54 over n cube from this summation, and 9 over n squared from this summation. And we have this. Limit n goes to infinity, 54 over n cube, summation I squared, I from 100, plus 9 over n squared, summation I from 100. Now this one, we're going to use the formulas. So this one we have a formula n times n plus 1 times 2n plus 1 over 6. Summation I we know I say for n times n plus 1 over 2. Okay. Okay, now we just basically we simplify. Looks like it's 6 divided 54 is 9. And we can bring the 9n cube on the bottom. And similarly, here we can simply just write 9 over 2 and bring the n squared on the bottom. Okay, now I think one of the ways you have how many terms? 1, 2, 3, and here's n cube. So you can split this n cube into for each of these terms. So you say first n over first n, and then n plus 1 over n. There are multiplications because they multiply. And then multiply 2n plus 1 over the next n. You see here n times n cube. Okay? Similarly, we can do here. We can write n squared like n times n. So you write n over n, and the second n plus 1 over n. Okay, now we have to find the limit of all. There are three products. So we can break it down into three limits, product of three limits. So you have 9, limit of n over n, times limit of n plus 1 over n, limit of 2n plus 1 over n. Now plus 9 over 2, here you can break it down into product of two limits, limit of n over n approaches infinity, and times limit of n plus 1 over n. Now we're going to divide and simplify. So we do that one. So we get 9, limit of 1, n goes to infinity, limit of n over n plus 1 over n, times limit of 2n over n plus 1 over n, plus 9 over 2, limit of n over n, times limit of n over n plus 1 over n. We further simplify, we have a 9 times limit of 1, limit of, you see n over n is 1 over n. N cancel gives you limit of 2 plus 1 over n. Here n cancel gives you limit of 1. Here n cancel gives you 1 and limit of 1 plus 1 over n. And now we directly substitute n equal to infinity. So now we have a 9 times, well, limit of 1 is 1 because 1 is constant. So we have 9 times 1. And here we have a 1 plus 1 over infinity times 2 plus 1 over infinity plus 9 over 2. Again, limit of 1 is 1. And we write 1 plus and 1 over infinity. And remember, n number times infinity is 0. So now we have this 9, 1 plus 0, 2 plus 0, 9 over 2, 1 plus 0. So this becomes 1 plus 0 is 1 times 2 times 9 is 18. 1 plus 0 is 1 times 9 over 2, 9 over 2. Now we combine this one. So it looks like LCD is 2. So we can rewrite 18 as 36 over 2. So same denominator, we can add 36 plus 9, 45 by 2, and then if you use calculator, you get 22.5.